normal cedar tree. Let's see what happens when it comes in contact with a 6200 volt line. 30,000 up to 35,000 degrees. I'm sorry, 1/6 of a second, just like that. But sometimes there might not be no smoke or any fire. You know, due to the ground conditions, you might think, well, it's okay. Obviously, it's not hot because there isn't no fire. So you might come in contact with the tree or the bottom. Watch the bottom of the tree here. Electricity is always looking for that path to ground, and it travels through the tree, and if a person comes in contact with the tree, it travels through the person too. When I talk about 35,000 degrees in 1/6 of a second, what's the human body's tolerance for heat? You may know. Anybody have a hot tub? What's it set on? About 140 degrees, probably 103, 104 degrees. About 108, 109 degrees is the human body's tolerance for heat. We're talking about 35,000 degrees in 1/6 of a second. Body just ain't capable of doing that. Now, if you watch that cutout, what Ron did is he opened up the door, opened up the fuse on the cutout. If you watch the security light, he actually fuses the cutout with the tree limb. Electricity flows through that tree limb and the light comes on. Trees conduct electricity. There's so many things that conduct electricity that we don't necessarily think about or we take for granted. So, never cut a tree down where it's coming in contact with the power line. If a tree falls in the power line, or even a branch, never try to remove that. Never go close to it or near it. Always stay back. And give the utility workers room to do their job and make it safe for the public and everything. Contact KUB, contact the media line, and get your information. But don't enter the work site. Now, the next thing we do is we demonstrate an antenna. This could be a tower pole. Don't know if y'all hear, but tragically, this has been about 5 years ago. There was a Boy Scout convention in Maryland. They were setting up a tent, and Scout leaders let a tent pole get into the power line. 3 Scout leaders were killed, and 1 other employee. This is what happened. This could be an aluminum ladder. I'm sure everybody here has an aluminum ladder at home they might use. Anything made of metal. Let's see what happens when it contacts the power line. Again, 35,000 degrees in 1/6 of a second. But I can't stress enough that due to the type of ground, due to the type of fault, it might not have that fire. It might not smoke. So you might think that it's okay. Watch the bottom if somebody walks over and picks it up. Electricity is always looking for that patch of ground. There's just as much potential at the bottom for the contact as there is at the top. And it will flow through that person. So please be aware of that. That's the hazard of electricity. Now what we do is we do a down power line. To me, this is probably the best demonstration we do to show the unknown hazard or the stored potential of electricity. What we're going to do is we're going to take a ground mechanical here and we're going to do a demonstration that would simulate the power line falling on the ground. Like I said earlier, you can't look at a power line laying on the ground and think it's safe. That's why it's so important to make sure everybody understands that there is a danger there. And that's why it's so important for KUB to go out and ensure safety by setting up work zones, setting up the area. Now what I do is, if you watch the red light here on the back of the truck, and you also watch the security light, is I'm going to make the truck off. When I do that, Mike's going to hold the down power line. Now if you see the security light on, you can see the red light's on, obviously we've got power interfering with my speaker back there. So, if you follow that mechanical up, you can see it's attached to the thing. It's energized right now at 6,200 volts. I want you to listen for a second. Can you hear anything? Can you see anything? In all reality, does that mechanical or that down power line look any more dangerous than a garden hose? It doesn't, does it? It looks perfectly safe. Look at the stored potential that's in this down power line. Just wait for somewhere to go, which might be your person if they come in contact with that. You can't look at a power line and tell whether or not it's hot. You can't see electricity, you can't hear electricity. Generally, if you do hear it, it's too late, right? Something's already happened, something might have gone wrong. So always be aware of that. Never consider a power line safe just because it's laying on the ground. Even if it's been isolated from KUB, it might be backfed from a generator to be laying on the ground and be energized. So always be aware of those hazards, be aware of those situations. Now, of course, antenna or things like that, we demonstrate they conduct electricity. What about a kite string? I'm sure many people use it. Seen kite strings used or fly kites. This is just a regular, everyday kite string. You can buy a kite string now that's stronger. It's got a steel fiber core in it. This is not. This is just a regular kite string. But you know if it's got a fiber core, a steel core, then it's going to conduct that much more. But watch the security light. Michael energized the security light with a kite string. Electricity flows through a kite string. Now, if the kite string conducts electricity, what about any other types of ropes? You know, any type of nylon, anything like any kind of cord we might be using for our electrical equipment or anything like that. Obviously, it will conduct too. What about a balloon? Got a balloon on the end of that kite string. You watch the security light? Electricity flow around that balloon to energize the security light. There's so many things we use every day that conduct electricity that we take for granted. So the important point of that is, anytime we're going to be doing any work, always look up, make sure that nothing we're using or we're going to be any tools or anything like that can come in contact with the power line, which includes trucks and equipment. Now we demonstrate here a ladder. This could be a line truck. This could be a fire truck. This could be a media truck with a satellite boom. Anytime you're setting up your equipment, always get out, look up, make sure there's no power lines above you. I've heard people say before, well, they got rubber tires. So obviously, there's some protection now. We're kind of like the TV show Mythbusters. We're going to kind of disprove that myth right now. But let's see what would happen if an antenna mast was raised into the power line, or if a fire truck ladder come in contact with the power line. You can see the fire at the tire itself. They conduct electricity. Now, OSHA says that you have to barricade the trucks or ground the trucks. We choose the grounded trucks at PIKE Electric, and we're going to do this demonstration again just to show that there's things that the industry does to try to make it safer. You ground the trucks for three primary reasons. First, to create enough ground fault to operate equipment, hopefully take the breakers out. That way it won't continue to burn, which leads us to the second reason, so the equipment doesn't burn up and catch on fire. And then the third reason, it does create a level of safety there. But electricity seeks all paths to ground, even if it's grounded, so there's still a hazard there. But we move the primary fault to the point of contact. We do that by attaching the ground to the frame of the truck and then putting it on the neutral. Now we're going to do the same demonstration as we did earlier. And when the contact is made, all ago we saw the fire at the top and the bottom. This time, if you notice, when the contact is made, move the primary fault to the top. But electricity is still flowing through that pilot ground. You just can't see it as much now. And we demonstrate that to just show you there's a lot of things going on at a work site or when we work around electricity that we have to do to make it safe for us. That we might not be aware of. Some people might not be aware of. Always take that into consideration when you're out there. Anytime you see any down power lines, never go around them. If a power line falls and comes in contact with your vehicle while you're in it, stay in your vehicle. Don't get out. When you're sitting in the vehicle, you're the same potential as the vehicle. Well, when you open the door and put your foot on the ground, you've created a path for electricity to flow through you to the ground. So always get on your phone, call 911, tell them the power line's coming in contact with the car, and you need the local service provider, KUB, to come out and assist you. If you see a situation where the power line's failing, don't go near it. Don't go close to it. Remember that step potential. But holler at them, tell them to stay in the car, stay in the vehicle, get on the phone, call 911. I have them send out the utility provider, KUB. Now, when I talked about opening your door and putting your foot on the ground, that created a path for electricity flow through your body. Now, this is a hot dog. This is what we demonstrate to show what happens when electricity flows through your body. Now, hot dog has a high concentration of water. It's got muscle tissue, similar in makeup to the content of a person. So let's see what happens when somebody comes in contact with the power line. And that could be somebody coming in contact with a down power line, somebody coming in contact with a tree, somebody coming in contact with a van that's got an antenna or a boom mast right on the power line. Indirect contact is just as dangerous as a direct contact. Now, of course, we use gloves when we're working. You can see Ron and Mike both have their gloves on. We have to test our gloves before use. This is a bad glove. We're going to demonstrate what would happen if somebody used a glove with just a small pinhole in it and it came in contact with the power line. That could have been a person. All right? We have to take special precautions to make it safe for us and make it safe for the public. So always be aware of that. That's an important thing, just so everybody understands the hazard and never get into a situation where they can come in. Now the next demonstration we do is we demonstrate a fireman's boot. There's another myth out there that tennis shoes, because they got rubber soles, or fireman's boots, things like that, will help protect you during electrical contact. But that's not true. Fireman's boots, tennis shoes, they're not dielectrically tested. They're not made to protect somebody during electrical contact. They're waterproof. And they protect you from temperatures somewhere around 1,600 to 2,400 degrees Fahrenheit. Remember, in electrical contact, you're dealing with temperatures of 35,000 degrees see what kind of protection this fire boot would offer this person if they make contact with the power line, this firefighter. Again, that could be the truck or a tree or anything like that in contact with the power line. So never think that you've got, work boots or something like that that will protect you. Now, if you notice, we're all wearing overshoes. We do wear overshoes as a level of protection because they're dielectrically made boots. They're specially protected. And this is a bad overshoe. Let's see what kind of protection the bad overshoe would offer somebody with a small hole in it. No different than the fire boot. It didn't offer protection. Now we're going to demonstrate a good overshoe. Good overshoe, people say, how long does overshoes last? Well, there's not an expiration date on them. You got to take them off and visually inspect them, just like all different types of PPE. This is a good overshoe. An overshoe that will offer protection from incidental contacts. We don't wear them so we can come in contact with something. We wear them just in case something goes wrong, in case the wire breaks. And if you watch the security lights, you see you've got power, no fire or anything. So there are levels of protection out there that we can use to make it safe, for our workers, for ourselves. Overshoes are not required by OSHA. You have some places that use them, some places that want. But we just want to demonstrate that so you know there's a lot of things that go on to be able to work on power line safety, and to make it safe, when you're in vehicle accidents or outages or car wrecks or anything like that. We want to make sure everybody understands the hazard that not only in coming in contact with the power line cause an accident, but just getting close to the power line can cause an injury or harm due to that step in. Now, I know y'all enjoyed the demonstration. I know it went kind of quick, and we've got some other things that y'all are going to be seeing. If anybody has any questions, we welcome those questions at this time. Pretty straightforward, right? I mean, that's the thing with electricity. There's a lot of hidden potential there. They just love electricity. Electricity, is a wonderful thing. We use it every day for almost everything. But we have to respect electricity anytime we're out there in the field. That said, I'm going to give it back to Leslie there, or Grace.